This is the proposed Mall of Asia to EDSA Taft aerial cable car line. This is Part A, part of a series of videos that will be devoted to this line. Last September 22, 2021, a Memorandum of Agreement was signed between DOTR, City of Pasay, and SM Group for a monorail system between MOA and EDSA Taft. This is a news article of the MOA stating the highlights of the project and the major conditions of the agreement. The mode of transport stated in the agreement is a monorail. The alignment is shown by this dashed blue line. The monorail line consists of only two stations, namely the MOA station and the EDSA Taft station. This is a perspective view of the MOA station. The circular footprint of the station will replace the circular footprint of the MOA rotunda containing the MOA globe. This is the perspective of the EDSA Taft station. It is located below LRT1 beside the corner of Metropoint Mall. Since it would be expensive to demolish and elevate LRT1, it is possible that the monorail station will be placed before reaching LRT1. This is the LRT train track that may be demolished so that the monorail can be connected to the MRT3 end station. Travel distance and interconnection. This is a map showing the alignment of the two mass transportation alternatives. The travel distance of the monorail is 1.9 kilometers, while that of the ART is shorter at 1.8 kilometers. Travel in ART is always the shortest since it travels in straight lines. In basic math, we know that the shortest distance between 2 points is a line. As to how ART and monorail interconnect with other modes of transport, we will show an example at the EDSA Taft interchange. This is the passenger tube that connects MRT3 to LRT1. This is an example of how an ART station can connect to another mass transport station by means of a passenger tube. This is a satellite photo of the multimodal mass transport interchange at EDSA Taft. This will likely be the location of the monorail station. This will be the passenger tube that will connect the monorail to the EDSA Taft LRT interchange. This will be the likely location of the ART station. This will be the passenger tube that will connect the ART to the EDSA Taft LRT interchange. This is a comparison of the right-of-way requirements for ART and monorail. The monorail requires a larger right-of-way. The monorail goes in 3 directions. The ART can do the same in also 3 directions. Additionally, it can go westward towards the ongoing SM reclamation project. It can easily fly over the MOA building, whereas the monorail cannot go westward because it will hit the MOA Mall. The size of the ART MOA station will be bigger than the EDSA Taft station. It needs to serve the additional 3 directions and will likely host the ART depot. Monorail stations are usually placed along a road, whereas ART stations can be placed almost anywhere. An example is these 5 location options enclosed in this yellow rectangle. If it is not possible to locate the ART station within this yellow rectangle due to difficulty in acquiring right-of-way, then the station can be placed on top of the road at EDSA. ART planners usually recommend an ART station to be on top of a road only when there is no other better option. This is to preserve the beauty of a city skyline seen by passing motorists and pedestrians. An actual example of an ART station over a road is in the Bush ART station in La Paz, Bolivia. The projected station footprint is only 1,100 square meters. The EDSA Taft ART station on top of EDSA will be slightly bigger since EDSA is wider than Bush Avenue. The best location for an ART station above EDSA is at the location of this pedestrian flyover. This flyover needs to be removed to give way to the ART station. Its replacement will be integrated into the ART station as shown in this example. Let us take a close-up view of the sample station. The passenger tube will be immediately above the road clearance, and the ART passenger platform will be immediately above the passenger tube. Whichever side of the road you are on, you can easily, quickly, and conveniently enter or exit the passenger platform to proceed to your destination. As in an LRT, you cannot cross the ART travel pathways. You need to use the passenger tube below. Because of the limited space, a passenger terminal cannot be made along a sidewalk. In its place are 4 bus pocket lanes for bus deboarding and boarding only. Other ART station amenities can be made nearby, such as a parking terminal if space is available. You can observe that this bus does not block the flow of traffic along this lane while deboarding and boarding passengers for about 1 minute. Depot and end stations. The MOA-Edsa Taft monorail will have 2 end stations and 1 depot near its travel path. A depot is a place for parking, maintenance, and repair of the monorail trains. This is a photo of a sample monorail end station and a photo of a depot. The depot will likely be located on this side of the corner of EDSA and Rojas Boulevard. The buildings located here for possible removal are less expensive to acquire. In an ART, the depot can be placed below or beside the passenger platform. In an end station, an arriving train has to do a backing maneuver to be able to travel in the opposite direction. It does this by track switching at this location. From a depot, a train travels from its parking bay towards the working track during opening time. During closing time, the train needs to go back home to the depot. It does this by track switching at this location. This is how track switching works in a monorail. Track switching in an end station and in a depot is similar to what is shown in this video clip. The track switching mechanism of a monorail is much more complex and expensive to build and operate compared to an LRT. In an LRT, track switching is done by simply pushing or pulling the red-colored switch rails. This is a simulation of an LRT when it moves in a rightward direction without track switching. This is a simulation of an LRT when it switches tracks. To switch tracks, these switch rails are simply pushed forward. For comparative purposes, these are the locations of the end stations of the ART and monorail. The depot of the monorail is located here. The depot of the ART will likely be located in the MOA end station where there is plenty of space. In an ART end station, there is no track switching like that of a monorail or LRT. The cabin just loops around to change directions and continue their travel. This is a sample ART station in Hong Kong with its depot located below the passenger platform. The process of cabins entering or exiting a depot is very simple. For example, from the passenger platform, ART cabins proceed to the depot below by traveling downwards through the overhead rails. This is a photo of the cabins inside the depot when not in use or when being maintained. At this point, it is easy to conclude that depots and end stations in an ART are simpler and less expensive to build than those in a monorail. In the case of the MOA station, the depot can be located on the second floor below the passenger platform. To save on space, the open-air terminal for jeepneys, buses, and bikes can be located instead on the first floor. These are the comparative photos of the depots of a monorail and an ART. The space occupied in a monorail depot is much bigger than an ART depot because space is needed to maintain the complex machineries of a monorail train. This is a photo of an ART depot during closing time where cabins are stacked side by side. The depot stores the cabins of a line consisting of several stations. There is very little maintenance work in an ART depot since cabins are simply passenger carriers. The propulsion mechanisms are located at the station. This is a photo of an empty depot during opening hours. ART versus monorail features. There is no two-station monorail system in the world that is less than 2 kilometers and has a capacity of more than 4,500 passengers per hour per direction. It is just not economically viable. Whereas the latest model ART system can reach this capacity and can be economically viable. One of the reasons MOA ART capacity will most likely be greater than the MOA monorail capacity is because the gap between cabin rides is 8 seconds, while that of the monorail will be between 3 to 10 minutes. The monorail ART system will need only one electric motor to drive 150 cabins around the loop between MOA and EDSA Taft stations, whereas the monorail will need 48 electric motors to drive the 2 train sets between MOA and EDSA Taft stations. Because the MOA-Edsa Taft monorail alignment is very short at only 1.9 kilometers, only 2 monorail train sets are needed. In comparison, the MOA-Edsa ART would need 150 cabins to match the capacity of the 2 monorail trains. This red line is the alignment of the Kuala Lumpur monorail. It consists of 11 stations and is 8.6 kilometers long. If these 11 stations were served by an ART system, it would be only 7 kilometers as shown in this blue line. It is now 19% shorter. Let us zoom in on the lower part of the monorail line. Monorail, like all other modes of transport, usually travels along a road. In very few cases, it travels along a river channel. The adverse effect is the degradation of the beautiful scenery of a river channel. The monorail alignment that mostly follows a road is shown in this red curvy line. ART travels in straight lines or shortcuts. For example, there is a passenger marked as a star that wants to travel from KL Central to Bukit Bintang. If he takes the monorail, this will be his travel path. If the same route would be an ART system, that same passenger marked as a triangle would travel this path. From this drawing, it can be seen that mass transportation systems that travel along roads such as monorail, LRT, and BRT need to navigate through curves. So much energy is wasted because the travel path is lengthened with no benefit. Transport vehicles need to slow down when encountering curves. It is dangerous to travel at high speeds along curves. Frequent deceleration and acceleration results in higher electrical energy consumption. A good indicator of the viability of a transportation system is its daily ridership. For an apple-to-apple comparison, the highest ridership per kilometer of both systems can be compared. Using the data of the La Paz ART, we can estimate the projected ridership of an equivalent Kuala Lumpur ART to be more than double that of the Kuala Lumpur monorail. Moreover, it is cheaper to build and operate on a per-kilometer basis. This is a satellite map of the same comparative travel path of the Kuala Lumpur monorail line versus a projected ART system line. The travel distance advantage of an ART is obvious.